I have my equation, did that answer your question, Ellen? Now that I have my equation for velocity, total distance traveled is done on an interval of time, right? On my t variable. So I need to find out when the velocity is 4 and when the velocity is 10. So when is the velocity 4? Well, you're just setting velocity equal to that. This is going to be 0, you subtract 4. So I'm going total distance traveled from 0 to, well, when is it 10? Subtract 4. I still have not answered the question. I need total distance traveled from time 0 to time 2. So now I'm going to integrate, and I'm going to integrate velocity from 0 to 2. Velocity is 3t plus 4. That's never going to be negative. This has got to be absolute value, remember, but because this graph looks like that, between 0 and 2, it never goes negative. Are y'all tracking with me?
I think that's right. There's no point.
Why is that not right? It is. That's what I said. You don't have to worry about it. Okay, so this is going to be 3 over 2t squared plus 4t, and I'm evaluating from 0 to 2. So I plug in 2, and then I plug in 0, and I subtract the 2. So 3 over 2 times 4 plus 4 times 2. You plug in 0, you just get 0. 6 plus 8. 14, what's my units? Meters. 14 meters, which is good. That was an involved one. That would be one of the last ones on there. I find they tend to get harder as you go on. Choice and stuff. Yeah.
Would we have that kind of thing on our test?
Yeah.
This test?
Yes.
Not our AP test.
Yes. When? It's gonna be a lot. You will. You'll have each week. You'll take a practice exam.
You're joking.
And then you have Barron's. It's all. I have a whole calendar. I give you. Yeah, I'll show you.
They do like a full
On yes, every other week you'll finish it. So like 1 week you'll take the multiple choice part. 1 week you'll take. Position. No, why ask this one?
That's like top theoretical way.
A and B are constant. When's it at rest? I'm gonna call this t squared minus bt minus at plus ab.
Now let's take the derivative.
Notice A and B here, it says they're constant. So what's the derivative of a constant?
It's just a constant.
No, the derivative of a constant is 0. The derivative of a constant with a variable is the constant.
Okay, I'm talking about the t.
Okay. Those are not constants. The A and B are constants. We need you to stop with that bottle.
The bottle down. Good Lord. Please, it makes me excited. Call me a bad boy. Please.
Logan, do you talk like this at home?
Yeah. Dude. So we were all going
in front of your mother?
Miss McGee, hold on. I killed right now. You went over to his house. I think it was like after volleyball game, the volleyball game. We go over to his house. Don't tell the story about how he smacked.
Dude, I'm sitting there and I'm talking with Logan and Charlie and
Hold on, you
Tell
gotta tell
somebody
the
else.
whole story.
Charlie and somebody else walk in and like his mom's like on the counter like with the album.
No, my mom has been over on the counter,
And so Logan.
and Charlie walks by and stares at her.
And
Walking
so
by.
Logan, to make it better,
When is it at rest? It's at rest when velocity equals 0. What is velocity? Here is velocity. When does that equal 0? Solve it for t, so add the a and the b, and then divide by 2. A plus b over t, which is, a plus b over 2, which is b. If you flip over to the FRQs for just a second, Sonny, you were asking about the justification, especially if it's a calculator problem. So if you look at like number 6, I think we did 16 together. We did. Oh, we did. Okay. So on 16, that's a calculator, right? But every one of them follows up, or A and B follow up with a why or explain or justify or something of the sort. So I put some stuff on here so you would know. These are almost always, used to be back in the day, you could do a sign analysis and that counted as your justification. Who gave him that? Noah, you're in charge of keeping him right, because it's weird. It's really weird. Okay. I know. Logan, do you need to go sit outside? Do you need to go sit outside? Because we're doing a new lesson today, and it's about, it's like the next to the last lesson we do. Between two curves.
No, look, now I can't reach it.
Okay. All right, look. Shh, Logan.
Oh, look at that. I'm sorry.
It was a joke. Joke. All right. Yes. All right, look, this is a calculator problem, and I do want to take some time so that you know how to use your calculator to your best advantage. Notice the little bit of work that I have on this one because it is a calculator problem, but you do have to include that justification credit. So he always kept it in this podium and it's gone. It's usually your answer point. Well, no. I guess if it's a calculator, it's gonna, Kenzie, it's gonna be like, if it's 3 points, your justification is probably 2 and your answer is 1. And there won't be anything else to do with it. That'll be it. All right, so let's look at it. Let's look at part A. So it gives you this equation for velocity, right? V of t is t sine t squared. I'm gonna go ahead and put that in here because I'm gonna keep referencing it. X sine x squared. Do make sure, get in the habit of always pushing mode and make sure you're in radians. You're gonna get all the wrong answers, and they're mean on the exam. They'll give you the choices if you had your calculator in degrees instead of radians. So make sure you're in radians because they're just mean. Okay, in which direction, up or down, is the particle moving at time 1.5? Well, this doesn't require you to do any calculus. It just requires you to understand what's going on, right? When velocity is positive, it's moving to the right or up. And when velocity is negative, it's moving down or to the left. So all I did was I went into my table and I said, remember, this is the equation for velocity. So with velocity, at 1.5, it's positive, right? The value itself doesn't matter. This is 16a. Plug in. I'm in my table. Second class. I plug it into the velocity because velocity at 1.5 velocity at 1.5 is 1.167. And all I did was I said, this is positive, yes? So V of 1.5 is positive. Therefore, I'm moving right at time equals 1.5. Or you can say I'm moving up at this time because velocity is positive, or however you choose to say that, but you have to give that justification or that reason. All right, then part B says find the acceleration at time 1.5. Well, what's the relationship between velocity and acceleration? Derivative. So I'm going to go back to my calculator. So if I come back in here, remember it's still, my equation's still in y1, and I'm going to keep it there as I go through. I would not advise you to erase it, even if another part asks you for another equation. I would go in and type it in y2, because most of the time these FRQs are going to keep going back and referencing these same equations. So I'm going to come here, I'm going to do math, and I'm going down to inderiv. The derivative of y1 with respect to x at what point? 1.5. Now it says, so that's the first part. What's the acceleration? -2. And this one didn't give me units, so I don't have to worry about units. But then it says, is the velocity increasing or decreasing at this time? No, it's negative. So is it increasing or decreasing? Decreasing because acceleration. So they're testing you here to make sure you understand that the sign of the derivative tells you what it's doing, right? So if I want to know if velocity is increasing or decreasing, I look at the sign of acceleration. If I want to know if the position is increasing or decreasing, I look at the sign of what? Which is velocity. Okay? So that's all they're doing here is checking to make sure you know that. What? Yes. That's your rule. So speeding up, and that's a big one that comes in a lot on these type of questions. How do you know if it's speeding up or slowing down? If the signs of velocity and acceleration are the same at that time, it's speeding up. And if the signs are different, then it's slowing down. Both positive or both negative, then it's speeding up. Part C asked you, given that y of t is the position of the particle at time t and y of 0 is 3, find y of 2. You could have also used, I probably did a little more work than what I had to do here, because you could have technically used fundamental theorem here. But, okay, well, let me show you because you need to know how to do that. So this says that y of t is position, y of 0 is 3, find y of 2. And so, and this is really like your x or your s. Do you agree that the integral of velocity is position? Right? And if I put bounds in here, then this would be position at B minus position at A. Yes? Well, what you can do with this fundamental theorem, since you have your calculator, is you can say, all right, look at these two different values they gave me from 0 to 2. I can say, all right, well, I'm going to integrate from 0 to 2. I've got that velocity equation. It's still stored in my calculator, remember. That's the t sine t squared. I ended up doing it by hand, and that was silly because this is a calculator problem. But do you agree that this would be y of 0 minus y of 2, or x of, oh, sorry. Do you see what I'm saying here? Because that is fundamental theorem, yes? Yeah. Do you understand this one? X is the same thing as S, Y is the same thing as S or X, whichever. They said position. That's what they're using to call position. The antiderivative of velocity is position. So to do the antiderivative, you go back one and it's upper bound minus lower bound. Okay, so that's all I've done here. This is velocity. This is position and position. This is on my calculator. I've already got the equation in my calculator. Instead of doing inderiv, you do the integral. No, you don't even have to graph it. You can do it the same way you did inderiv. That's right. I'm still with respect to x, but I go from 0 to 2. If you want to graph it, you can. If you graph it, it shows you the shaded part, or you can do it here. Um, 8268. Do I know y2? No, that's what they asked me to find, right? But I do know y0. What is it? 3. Right? They gave me that initially. So what is y of 2? 3.826. I didn't find the exact answer. I put -1/2 cosine 4 plus 7 over 2. But it equals the same. It should equal the same thing. Remember, if you are on FRQ, there is nothing wrong with leaving this answer like this. If you could type it into a regular calculator, you can leave it like that. I just plugged in what I got whenever I did it by hand and showing you that I got the same thing. The calculator way is a lot easier if you know how to work it, if you recognize it being fundamental theorem. Yep, because I've got this equation, right? And so I just solved it for y of 2. Then part D is total distance traveled from 0 to 2. You can do this a couple different ways on your calculator. Remember, this equation is still in my y1 and I keep referencing it. You can go into y1 and you can add an absolute value in front of it, or you can just do math, integrate, and I can put the absolute value here. And I can say absolute value of y1, comma, x, comma, 0, comma, 2. What? Yes, yeah. Because this is the absolute value of y1. It's still thinking. It takes it a long time to calculate whenever you start doing more things to it. But there you go. Same thing. Here I did it in y1. In y1 I put absolute value of this. For this one I put it here. Either way works. Does that make sense? Why are you letting me so confused? So, but part of this is learning these little tricks that help you get through, because you want to get through the whole test. It is a time test. So you want, if it's a calculator problem, you want to learn to rely on your calculator for these kind of things and use it the most efficiently. Okay. What? It wasn't addressed. Logan, she was negative. Quickly approaching, we have got area between two curves, we have got cross sections and volumes, and that's it.
Hey, Garrett, go away.
All right. Listen, every day y'all say, please not today. I also got y'all's Barron's books in, so we'll get to dig into those really soon.
Hey, did everyone order the AP book like we were supposed to?
All right.
Yeah, I never.
Barron's books. That's what we'll do all our multiple choice practice in. All right.
Does the math department cover that?
Getting a little more complicated with it.
When we started. Why?
I don't know though. I don't think it's really hard.
Don't even get anything responsible anymore.
But I'm not gonna lie, Wyatt. I'm not a fan.
That's the national anthem of all time.
Fergie?
The real one.
And her name's not Fergie.
Oh.
It's Fergie.
It's not a function. It is in fact two functions, Dozier. So we're going to find the area between two functions. We're going to start easy today with respect to x. Tomorrow we'll add with respect to. It's not. It's two different functions. It's f of x and g of x on a coordinate plane. What if I want to find the area of the shaded region? Now,
Trapezoid.
I don't think I'm even.
Rectangles.
Okay, we could do rectangles.
Wait, can't.
Yes, you can. No, you can.
You actually can't, because rectangles are 5 parallel sides and you won't have 4 parallel. That's not right, though, because.
They're not exact, right? They're not exact, which is the point that they're getting to there. Is that it's not an exact amount.
So you can't even get the right answer.
If I did the integral of f of x and I ran it from a to b, there's not one for this. Okay, that, look, I'm gonna do pink. Pink would give me this, and this, right? That's exactly what we're gonna do. Did you come up with that on your own? I did, because what I was showing you was f of x, that's f of x. The integral from a to b of g of x runs, remember, start at the curve, go up to the axis. The point of the matter is to find the original between just the two curves. What you're going to have to do is the integral from a to b, and you're right, I'm going to subtract them. It's f of x minus g of x. It's always, always, always top minus bottom. Because g of x is the bottom function, f of x is the top function. It's always the integral of the top function minus the bottom function. That's it in a nutshell. Now it. What?
Wait, let's just count this.
No. Now I could have to divide it. Yeah. Yes, what I started with in life is what you get whenever you subtract.
Oh wait, we used the
Yes.
diagram theorem here, right?
No.
You use stuff in example.
Why is it an exponent?
What are they talking about right now? Let's do an example. Yes. Okay. Why I am going to.
What's the song even called, right? I didn't know.
It's on his Chromebook. I told you.
Cut that off. Kenzie, put your computer away.
Yeah, it won't cut off. It's on his thing. That was on his Chromebook. Start it up. Start it again.
I'm gonna just give y'all your homework and let you do it. What? Thank you. Find the area between the curves from 0 to pi over 4. Mark, set, go. You may use your calculator. No.
Which one's f of x and which one's
Doesn't matter. You have to decide which one's on top and which one's on the bottom.
We can use our calculator for calculator.
Okay, no calculator.
No. Why'd you say that? That's so stupid. Wow.
But it's squared, so it's got to be 1 over cosine x.
Oh, so that's crossing the line. You hope like that's my color.
You gotta do.
Okay, well, it's better than you saying you go by crash.
X.
The X is outside of them.
It doesn't matter. Same thing. Close, square. Okay, you can use your calculator to graph. You can. I was just being, but you can use your calculator to graph it.
How do you graph secant?
1 over cosine. But when you do it, the whole thing is squared. Okay, so once we got the graph, how do we know which one's on top and what's going on, right? If you hit trace when you're graphing, go back. What did you do? Quit. Do zoom trig. Zoom 7.
So what are you doing? And what is that?
You're kidding.
You are
Still late. Still late.
All right. If you graph this,
is
right, you'll see you've got these funky ones like this, right? And then coming down below, you got this going on, right? All right, so look, this is your sine graph. This is your secant squared graph, okay? So if you're doing top minus bottom,
So it's
secant
1 over
squared's
cosine.
always on top, right? So I'm going to do the integral from 0 to pi over 4 of secant squared x minus sine x. We're going to do this one by hand, though. I'm going to show you how to do it by hand. Yes, but that's just going to give you of the first one. Yes, that is. And then you can subtract.
But then you subtract it. You subtract. Could you subtract like?
All right. Because I'm subtracting here, I can split these integrals up. What's the antiderivative of secant squared? Tangent. So what I really have is tangent x. What's the antiderivative of sine? So it's minus negative. Nope, just minus cosine. Nope, yeah, minus negative. So plus cosine. And these I am evaluating from 0 to pi over 4. So we got to do pi over 4 first. I got tan pi over 4 plus cosine pi over 4 minus tan 0 plus cosine 0. Tangent of pi over 4 is cosine of pi over 4. Yes. Minus, what's the tangent of 0?
1, 0,
God.
0.
0, so cosine of 0 doesn't matter because this is just 0. So 1 plus root,
Whoa. No, it's
That
1.
is not right.
oh, because it's plus, it's plus, it's plus.
Oh, would you look at there, man? Yeah, look, I corrected you this time. You would look at that.
Technically, it's minus 1 because it's negative.
So technically,
That's just square root 2 over 2.
now,
All right, that's right.
one more. Let's do one more that's not a trig. I don't know, this will be a non-calculator.
What are you talking
What's that on my phone? Find the area enclosed by, do this by hand, no calculator. Find the area enclosed by these two. If it's non-calculator, how do we find how do we find
Whoa.
what's on top? What else am I missing?
What are the points?
I didn't give you points. I said the area bounded by the two curves. Is it? I don't know. What do they look like if you graph them? Why don't you? This is a quadratic that's up to, it's going to cut this up to and down.
Shut up.
That's fine. Y equals negative x. 0, 0. It's a down slope over 1, up 1, right?
Oh, it's going to be that little cut through.
That little cut through, Logan says. What little cut through, Logan?
That one doesn't say where that is.
Now,
Hey, who said Lori's kind of bad? Yeah?
I know it's top minus bottom, right? I know it's going to be the integral of top. What's the top curve? 2 minus x squared minus the bottom, negative x. But I need these bounds.
You suck.
It's where it intersects. How do you find where two graphs intersect?
With your calculator, but set them equal to each other.
Yes, set them equal to each other. If I have, all right, here we get into the good stuff. Where does this equal? Well, that looks like a quadratic to me.
Oh, quadratic formula.
Even easier than that, though.
Y was going to be x. Oh, x equals 1. 1 and 2, negative 1. Oh my God.
Does that make sense on my graph?
What's your dot? That would not make sense. What's that other guy?
Okay, what dots? What dots are you looking at? Okay. So I'm going from -1 to 2, right? If I set them equal to each other and I solve for x, I can find where these two curves cross, where they intersect. So now what I'm going to say is that I am finding the integral from -1 to 2. So sometimes you might want to go in and find these bounds, and I want you to understand. Yeah, so now this is a problem like you've done before, right? The new stuff here is finding where they intersect, finding what I'm running from. Which dot?
The one under the.
I was just graphing that line. All right. I'm going to assume that you guys can solve this.
Never
You can-
assume it. You know they say about assuming.
Brother, can y'all? Okay. You don't really need the y. The y is irrelevant. I put them in there just because I was being extra, but no, you don't have to. These don't matter. Because for your bounds, you only need the x. But if you plug them back into the equation, you'll find the y. Dozier, do I need to lock your computer down? Antiderivative. I don't know what the actual answer is. We'll plug in 2. We'll plug in -1. Technically, if you were an FRQ, you could stop right there. But if you do all this, you get 9/2. I did that in my head.
Oh. Oh, you do a math of 30 years.
My answer was in the book.
Wait, you go.
Ready to stop? Haven't had enough?
This monkey looks at homework.
Alright, stop it.
Did you call me a monkey?
Sandberg asked.
Breathe.
What I think is basically. Sorry, volume.
Was that the first time? That was the second.
Can you give us the homework?
Find this with your. You can't mention a word.
Wait, why?
We just let the chips fall as they may.
Miss McGee, why do you want us to still
What? Who's on their phone?
If I win, what do I get? This magazine.
I don't know. We didn't set any parameters. No.
Actually, it's during
Wait, you said what about that?
What were my 2 equations?
Wait, what number?
2 cosine what?
What number is this?
Cut that off. Cosine what? Blade.
What number is this?
What was the other one? X squared minus 1. All right, this is not a number. I'm just showing you how to do this. If I'm looking for area between the curves, you see the area I'm looking for? Which one's on top? The cosine one, right? I'm going to do second trace, and I'm going to do intersect. All you have to do is be close to the point of intersection for it to do, because notice there's 2, and I'm going to need to calculate both of them. You just have to be kind of close to it, enter. So I'm going from -1.26. Yeah, the sign is up top, because if you follow the sign. I haven't been Miss Galls in a lot of years. And then intersect here.
You can call it whatever you want to call it, actually. Like, I don't call you Miss Carrot, but like, you still wear a carrot from birth.